the Laplace transform of f of t is given by f of s, then we will be interested in obtaining the Laplace transform of e to the power at f of t. Okay, so here let f of t has a Laplace transform of f of s. Okay, then all what we need here is to find the Laplace transform, or we can state the theorem and then we can prove it. Okay, the Laplace transform of e to the power at multiplied by f of t is equal to f of s minus a. Okay, and this is called frequency shifting, okay, or shifting in the s domain. So in order to shift the function f of s by a units in the frequency domain or in the s domain, all what you have to do is to multiply the function f of t by e to the power at. Okay, now let me prove this result. Okay, so here we have proof. Okay, now we can start from the left-hand side. So the Laplace transform of e to the power at multiplied by f of t, this one is equal to the integral from 0 to infinity. So we have this function e to the power at f of t, e to the power minus st. So all what we can write is the following: e to the power minus s minus a t multiplied by f of t dt. Okay, now think of this one s minus a, think of it as v. So here we have the integral from 0 to infinity e to the power minus v t f of t. And what do we get here if we substitute v in here? What do you think? What is the integral e to the power minus vt f of t in terms of the Laplace transform of f of t? So this one is f when s is equal to v. So basically f of v, okay? Where v is equal to s minus a. So finally, what do we get here is f of s minus a, okay? So the Laplace transform of e to the power at f of t is equal to the Laplace transform of f of t being shifted by a units, okay? Now in this case, okay, is this clear? Do you have any questions so far? Is this clear? Okay, so here we can consider some examples. So this is the first example. So here we are interested in obtaining the Laplace transform, of course, but before that, let me write the following. So here we have the Laplace inverse of s of f of s minus a is equal to e to the power at multiplied by f of t. Okay, this one follows immediately from the result in here. Now here we have some examples. So the first example, we have e to the power alpha t, let me say e to the power at, e to the power at. This is f of t is equal to e to the power at multiplied by cosine omega t. And we need to find f of s. Okay, how do you find f of s? So here this one is being written in the form e to the power at multiplied by f of t. So يعني here, if you don't like this one, you can have here g of t, for example. Okay, so in this case, what do we have? We have now the Laplace transform of cosine omega t. Okay, now we need to shift it by a units. Okay, so the Laplace, we know that the Laplace transform of the sine of the cosine omega t, so here the Laplace transform of cosine omega t is equal to s divided by s squared plus omega squared. Okay, so it turns out that the Laplace transform of e to the power at f of t, e to the power at cosine omega t is equal to, again, if you multiply by e to the power at, then you shift the s domain, or basically you shift the function f of s by a units, okay, to the right. So here we have s minus a divided by s minus a squared plus omega squared. Okay, so this is the Laplace transform of e to the power at cosine omega t. Okay, so what about f of t is equal to e to the power at sine omega t? This is another example. Excuse me.
لا بتجاوب فيها قاعد.
Okay.
اوميجا ماينس 1 و
اوميجا
اي
ماينس 1.
سكوير.
ليش اوميجا ماينس 1؟
عملت شفت لنفس الشيء.
So first of all, you need to find the Laplace transform of sine omega t. So the Laplace transform of sine omega t is equal to omega divided by s squared plus omega squared. All right? Now shifting by a units, okay, or multiplying the function by e to the power at implies that we shift the s domain function or the Laplace transform by a units. Okay, so what is f of s minus a? We have to replace every s by s minus a. S minus a squared plus omega squared. I don't understand from where you get 1. You said 1. Okay, مش عارف شو ال1. يزن أنا بحكي معك.
أنا فكرت إنه بنعمل شيفت للدبليو. ذكرت ناس ثابت كونستنت.
Okay. So this is sorry, here this is the Laplace transform. So this is the Laplace transform of e to the power at sine omega t. Okay, so here you have to shift this one by a units. Okay, so here replace s with s minus a. Every s with s minus a. Of course, now this is valid. Remember, the cosine omega t has a Laplace transform of s is as long divided by s squared plus omega squared as long as s is greater than 0. So now after shifting by a units, this is valid for s is greater than a, and again this is valid for s. Here s is greater than a. Okay. Any questions so far? Any questions? Okay, so here we have the following example. So f of s is equal to s minus 14 divided by s minus 7 squared, okay, plus 50 squared, okay, and I need to find f of t. Find the time domain representation or the time domain function f of t. What do you think? How do you find f of t? We have to find the Laplace inverse, okay, or the inverse Laplace transform of f of s, okay. In this case, now remember, this is written now in terms of s minus omega plus s minus a plus squared plus omega squared, okay. So all what we have to do here is to express this one in terms of something we know, some Laplace transform we know. So remember, here we have s minus a divided by s minus a squared plus omega squared. So what about writing this function? So we can start from here. F of s is equal to s minus 7 divided by s minus 7 squared plus 50 squared minus 7, because 14 is equal to 7 plus 7, minus 7 divided by s minus 7 squared plus 50 squared. Okay, is that okay so far? Okay, and what is the Laplace transform? So here f of t is equal to the Laplace inverse of this one, s minus 7 divided by s minus 7 squared plus 50 squared, okay, by linearity property, then minus the Laplace inverse of 7 divided by s minus 7 plus 50 squared squared, okay. What do you think? What is the inverse Laplace transform of the first function?
E to the power 7.
Cosine.
Yes, so this one is being written in the form of s minus a divided by s minus a squared plus omega squared. So here the inverse Laplace transform is this function, e to the power at cosine omega t. So here we have e to the power minus 7t multiplied by cosine 50t. And what about this one? So this one is being written in the form of omega divided by s minus alpha or minus a squared plus 50 squared. So here we have e to the power minus, basically in this case, what do we have? We have e to the power minus 7t multiplied by sine 70. Oh, sorry. Oh, this is wrong, right? Tamam. 1 second. So what do we have in here? So this one is e to the power minus 70. Okay, this one is correct, right? Do you agree with me, Jamaa, so far?
تمام دكتور.
Okay, so what we have in here is the following. So this is the Laplace inverse. So here we have minus 7. What is the Laplace inverse of 1? Okay, so يعني I will do this trick. Okay, بدي أحكي 7 over 50 multiplied by the Laplace inverse of 50 divided by s minus 7 squared plus 50 squared. Okay. Now what is the Laplace transform of this one? This one is being written in the form of omega divided by s minus omega squared plus omega squared, right? So here we have e to the power minus 7t cosine 50t, okay, minus 7 over 50 e to the power minus 7t sine 50t. Do you agree with me ولا لا؟ شو رايكم؟
دكتور بصير سؤال.
Yes, go ahead.
دكتور ليش كتبنا minus 7 إنه مش فوق كانت هي إنه a of a times t وحطينا إنه s minus a.
1 second, okay. Minus 7 هون. يا فرح I'm splitting this one. I'm splitting this one.
لا إنه بالفورم اللي فوق كنا حاطين إنه e to the power at بعدين إنه حطينا s minus a فإنه هون تحت إنه هي كانت s minus 7 فإنه ليش كتبناها إنه e to the power minus 70.
Okay. Just 1 second. Okay, 1 second. اوكي سوري اباوت ذات. اوكي احكي يا فرح ايش كان سؤالك؟
دكتور هلا بالفورم اللي فوق كنا حاطين
اي فورم شوي
هون اوكي
هون
انه كنا حاطين e to the power at بدنا حاطين انه هي s minus a فانه تحت انه كانت هي s minus 7 فانه ليش حطيناها e to the power minus 70 انه عشان مش مفروض تكون e to the power 70 ولا لا؟
لا يا هلا s minus a انا I want to write it in that form. اوكي تمام؟
تمام.
Okay, wait. Let's start from here. S minus 14, S minus 7. A is equal to 7, right? Well, omega is equal to 50. So this one, لازم يكون عندي sine 50 e to the power minus 7. Sorry, you mean 70. Yes, you are right. And you قصدك plus 7.
بالضبط.
Okay, my bad. I'm very sorry. Okay, أنا دايما هيك. Okay, so here we have plus 7. Yes, here we have plus 7. Okay, makes sense now?
تمام دكتور.
تمام اوكي let me double check خلينا نشوفها على الميبل فايل. Okay, so here let me share this one with you. Okay, so here we have inverse Laplace transform. So inverse Laplace. So what is the function in here is s minus 7, s minus 7 divided by s minus 7 squared. Sorry, we have s minus 14, right? S minus 14 plus here we have plus squared. Okay, انتوا شايفين الويندو؟ Okay.
اه دكتور.
لا دكتور.
Okay, after expanding this, okay, expand. Oops. Okay, so it's the same function. We have 50 over 50 cosine 50t e to the power 7t minus 7 over 50 e to the power 7t sine 50t. Okay. So this is the same answer we got in here. Okay, so that's what we have. Okay, thank you Farah for pointing out إنه هاي لازم تكون plus. Okay, يعني mistakes like this can kill you in the exam. Okay, I'm allowed to do such a mistake, but you are not allowed. Okay, تمام. Anyway, so خلينا هلا نروح على. Okay, that's all what we need to do in this case. So this is f of t. We find f of t by obtaining the inverse. This is finally f of t. Okay. Now we will talk about the existence and uniqueness of the Laplace transform. So here we have existence of Laplace transform. So basically, if f of t, we have the following theorem. If f of t is defined and piecewise continuous, on every finite interval on the semi-axis t is greater than 0. So basically we can see, okay, let me erase this one. For t is greater than 0, okay. For t is greater than or equal to 0, okay. Then, and we have the following condition, and this condition must be satisfied, then the absolute value of f of t is always less than or equal e to the power m kt. M and k are constants. Then the function f of t has a Laplace transform, or simply then the Laplace transform exists, okay? Okay, so this theorem says the following. If f of t is defined and piecewise continuous, okay, for t is greater than 0, and this condition is satisfied, okay, the absolute value of f of t is always upper bounded by m e to the power kt. For m and k constants, okay, then the Laplace transform exists, okay. So, and again, this is sufficient but not necessary. This is a sufficient but not necessary condition for the existence of the Laplace transform, which means if this condition is satisfied, then we are sure that we have a Laplace transform for the function f of t. Okay, it's sufficient to confirm the existence. Okay, but if this condition is not satisfied, or this theorem basically is violated, then we don't know. The function f of t might have a Laplace transform, or it might have no Laplace transform. The Laplace transform might be undefined for that case. Okay. Now, one interesting thing here, what is the piecewise continuous function? Who knows? Okay. Piecewise continuous function. What do we mean by piecewise? Have you heard about piecewise function? Continuous on all but a finite number of points in its domain. Okay, so here continuous on all, yani on all t except, okay, except a finite number of points in its domain. Okay, on all but a finite, must be finite number of points in its domain. Okay, so this is the piecewise function. Okay, a continuous function, okay, that is continuous everywhere except at a finite number of points in the domain. Okay, now again I should mention that the existence condition above, the is sufficient but not necessary. Okay, so which means that if the condition is satisfied, then this is sufficient to confirm that the Laplace transform exists. Okay, if the condition is not satisfied, we don't know. Okay, we might have Laplace transform for the function f of t, and we might have no Laplace transform. Okay. Now let me talk about the uniqueness of the Laplace transform. Okay, so now if the Laplace transform exists, then it's uniquely determined. In other words, if we have two functions, f of t and g of t, if the Laplace transform of the first function is f of s and the Laplace transform of the second function is g of s, such that f of s is equal to g of s, then f of t must be equal to g of t. Okay, which means if we have two functions, okay, f of t and g of t, such that they have the same Laplace transform, then we must infer that f of t is equal to g of t. It's one-to-one mapping. Okay, you cannot have two Laplace transform or two functions, okay, in S domain for one time domain function. Okay, you will get the same, you will have the same, basically you will have one Laplace transform for each f of t, for each time domain function. Okay, now the bottom line is uniqueness of the Laplace transform. So here we have, in this case, if the Laplace transform exists, then it's uniquely determined. Okay. So in this case, we can say that if f1 has a Laplace transform f1 of t, f1 of s, and f2 of s has a Laplace transform of f2 of s, such that f1 of s is equal to f2 of s, then we must have f1 of t is equal to f2 of t. Okay, it's a one-to-one mapping. Okay, now that's what we have. Now we want to use the Laplace transform in derivatives and integrals. Okay, so, and as I said, remember the Laplace transform is a powerful technique because of its properties, not the definition. Okay, so now remember last time we talked about the Laplace transform of the first derivative of f of t. Okay, now here the Laplace transform of the derivatives. Okay, of course, on integrals, let's start with the Laplace transform of the derivatives. Okay, last time we showed that the Laplace transform of the derivative of f of t, f prime of t, is given as s f of s, okay, minus f of 0. Okay, now here let me add the following conditions, okay, just for sake of completeness. Okay, so here f of t is continuous. On the semi-axis, t is greater than or equal to 0, and f prime of t is piecewise continuous. Okay, so here where we have two conditions here, f of t is continuous for all t is greater than or equal to 0. Okay, and of course, f prime of t is piecewise continuous. Okay, of course here f of t must satisfy the existence condition. قبل هيك بس خليني احكي هاي. Okay, because this is very important. Where f of t is continuous and f of t, remember f of t satisfies the existence condition. Okay, now in this case we have a Laplace transform for the derivative f of t. Okay, now my question to you is the following. Let's forget about the existence. Okay, I know that you don't like the existence and the definition of piecewise functions and these kind of things. You are interested in the applicability of Laplace transform in your area. Okay, now my question to you is the following. Okay, what is the Laplace transform of the second derivative of f of t? What do you think? And then we might have some conditions, okay, such that the Laplace transform of the second derivative exists, okay? Now, but before that, what is the Laplace transform of the second derivative of f of t? This is my question to you guys. What do you think? Nobody wants to answer? Go ahead, Jason. Go ahead.
نقول اس سكوير اف اوف اس مثلا ماينس اس اف اوف اس.
From where you get this? From where you get this formula? This very beautiful, nice formula. Are you copying it from where?
لا والله قلت
Okay.
بجرب زي الاكس زي مثلا اكس لينير وال.
Why do you want to try this one? This is my question to you. Okay.
تجرب.
Just s squared f of s, that's it?
لا ما هي اف سكوير قصدي اس سكوير اف اوف اس.
Okay.
minus
From where you get s squared f of s? This is my question to you. Apparently, you are reading it from a source.
لا.
Okay.
انتم مأمنين على العلامات.
You should think of the following, okay? We know, as of now, all what we know is the following. We know that the Laplace transform of f prime of t, okay? Now let us think of it. Let us think of f w prime of t, okay, as g prime of t. So if we assume that let g of t is equal to f prime of t, okay? Then g prime of t is equal to f w prime of t. Okay, then the Laplace transform of g prime of t is equal to the Laplace transform of f w prime of t. So from here, what we infer is the following. So the Laplace transform of f w prime of t, which is the required, okay, information here. So this is the Laplace transform of g prime of t, okay, because of these formulas. And now we can express the Laplace transform of g prime of t. So that's what we know, okay? The Laplace transform of f prime is f of s minus f of 0. The Laplace transform of g prime is s g of s minus g of 0, okay? Where g of s is the Laplace transform of f of t, of g of t, okay? Where g of s is the Laplace transform of g of t, okay? So that's what we get. Now, from this is, of course, this one comes out from the second equation. Okay, now from the first equation, what is the Laplace transform of basically g of t? This one is equal to the Laplace transform of f prime of t. Okay, and this one is equal to s f of s minus f of 0. Okay, so here we can have g of s. Okay, g of s is being defined as the Laplace transform of g of t. And since g of t is equal to f prime of t, then by uniqueness theorem, okay, we can have the Laplace transform g of t must be equal to the Laplace transform of f prime of t, and this can be expressed as s f of s minus f of 0. So it turns out that g of s is equal to s f of s minus f of 0. Now we want to substitute g of s in here in the formula, okay? So in here, okay, we want to use g of s as s f of s minus f of 0. So in this case, the Laplace transform of f prime of t, w prime of t, f w prime of t is equal to s multiplied by s f of s, g of s, minus f of 0, okay, minus g of 0, okay? What is the relationship between g of 0 and f of 0? Remember, from here, g of 0 is equal to f prime of 0. We can replace g of 0 and we can have f prime of 0. So finally, what do we get is the following: s squared f of s minus s f of s minus s f of 0, sorry, minus f prime of 0. Okay, so this is the Laplace transform of the second derivative of the function f of t. So finally, what do we get is the Laplace transform of f w prime of t is equal to s squared f of s minus s f of 0 minus f prime of 0. Okay, that's what we have. Okay, is this clear, Jama'ah? Do you agree with me so far?
دكتور تمام.
All right, so now let us think of the following. But before that, let me mention the sufficient conditions for the existence here. So in this case here, where f and f prime are continuous, and if w prime is piecewise continuous. All right, so of course f of t, all of them, f prime, f prime, and f w prime, okay, basically in this case we have the following. So f and f prime satisfy the existence conditions, okay, which means that f and f prime should be upper bounded by e to the power kt, or constant multiplied by e to the power kt, satisfy the existence conditions. Okay, now let me generalize this result for the nth derivative. When we have the nth derivative of f of t, what is the Laplace transform? Okay, so here we have the following theorem. Now let f prime and so on, f n minus 1, I mean here the n minus 1th derivative of the function f of t, be continuous functions, okay, for t is greater than or equal to 0, and satisfy the existence condition if f prime and if n minus 1, all of them satisfy the existence condition. Then the Laplace transform, of f n of t, the nth derivative, is given by, or is simply is equal to, the Laplace transform of f n of t. Okay, this implies the nth derivative of the function f of t. It's not f to the power n, okay, is equal to s n fs, okay, minus s n minus 1, here I mean s to the power n minus 1, f of 0, okay, minus s n minus 2, f prime of 0, and so on, minus f n minus 1 of 0, okay. So this is the basically the generalization of the previous results when we have n is equal to 2. Of course, the proof is not basically is not required, okay, as of now in this course, but you can proceed with proof by induction, okay? And in proof by induction, so this is true when n equals 1, okay? So if you substitute n equals 1, then you are interested in the first derivative, then you have to stop in here. So here you have s f of s minus s to the power 0, which is 1, okay, multiplied by f of 0. So s f of s minus f of 0. So it's true for n equals 1. Then you assume that it's true for n equals k, and then you need to prove that it's true for n equals k plus 1, okay? Once you did that, then you are done. The proof is complete, okay? Now, let me consider some examples where we demonstrate the applicability of the Laplace transform of the derivatives, okay? Now here, f of t is equal to t sine omega t. Find f of s, okay? How do we find f of s in this case? What do you think? So we know the Laplace transform of sine omega t. Okay, we know the Laplace transform of sine omega t, but we don't know the Laplace transform of t sine omega t. Now, what is the approach in here? What do you think? How do we use the derivatives here in order to find the Laplace transform of such a beautiful function? Nobody wants to answer? Okay. Okay. Now, starting from here, let us find the derivative of this one. So here, f prime of t is equal to, what is the derivative of this function? فرح شو الديريفاتيف؟
اوميجا اوكي اول شيء اوميجا ساين اوكي اوميجا تي ساين
بلس
بلس كوساين
cosine omega t. Okay, this is t مش plus. Okay, so f prime of t is omega t sine omega t plus cosine omega t. Okay, now what is having the first derivative, why this should be useful to us? Okay, so what do we get here? Okay, I think في a mistake. Yeah, there is a mistake. Yeah, I'm sorry. So omega t cosine omega t plus sine omega t. صح؟ هيك صح. Okay. طيب, so we find the first derivative. Okay, what is the second derivative in this case? And why are we interested in obtaining the second derivative? Look at this one. So here, this is f prime. So if you take the derivative of the right hand side, or if you take the derivative of both sides, basically, so here we should have some omega t sine omega t after taking the second derivative. So we can relate f of t to its second derivative, which means that f double prime of t is equal to omega t. Here we have minus omega squared t sine omega t plus cosine omega t multiplied by the derivative of omega t is omega. Okay, omega multiplied by cosine omega t, and here we have the derivative of sine omega t is again omega sine omega t, so we can write 2 omega cosine omega t. Now this form is useful now. Okay. Okay, so here from here, what we can infer is the following. Okay, so here we have minus omega squared f of t, right? This is f of t. Do you agree with me or la? Plus 2 omega cosine omega t.
بس 2 من وين اجت؟ ما فهمت. 2 اوميجا
الكوساين هلا الفيرست تيرم راح يعطيك هاي اول تيرم، الثاني راح يكون كوساين اوميجا تي ملتبلايد باي ديريفاتيف للاوميجا تي اللي هي اوميجا، فراح يصير عندك اوميجا كوساين اوميجا تي، وهاي راح تعطيك كمان اوميجا كوساين اوميجا تي، فراح يصير 2 اوميجا كوساين اوميجا تي.
دكتور انت اشتقيتها على السريع. تمام.
Yeah. Okay. Now, as of now, do you agree with this one?
دكتور تمام.
Okay. Now let's take the Laplace. This is a differential equation يا جماعة. This is a second order differential equation. Okay. Homogeneous ولا مش homogeneous? Non-homogeneous because we have a forcing function. F double prime minus omega squared f is equal to some function r of t. Now, in this case, let us take the Laplace transform of both sides. So here we have s squared f of s minus s f of 0 minus f prime of 0. This is the Laplace transform of f double prime. This one is equal to, what is the Laplace transform of the right hand side? احكي يا يزن.
إيه
minus omega squared f of s, okay? Constant phi f of t, linearity property, plus what is the Laplace transform of 2 cosine omega t? So we know that the Laplace transform of cosine omega t is s divided by s squared plus omega squared. So here we have 2 omega s divided by s squared plus omega squared. Now, we need to find f of 0 and f prime of 0. F of 0 is equal to 0 from here. Okay, so f of 0 is equal to 0. And f prime of 0 again is equal to 0 when you substitute 0. So here we can have this one is 0 and this one is 0. So finally, we need to solve for f of s. Okay, now here we have s squared plus omega squared multiplied by f of s is equal to 2 omega s divided by s squared plus omega squared. Or finally, what we have is the following: f of s is equal to 2 omega s divided by s squared plus omega squared to the power 2. Okay, do you agree with me so far? Do you agree with me يا جماعة ولا لا؟
كنت هو بس سويت نقلت حدود وليش سويت عشان تخلي في اس
f of s I divide by s squared plus omega squared. I'm solving for f of s.
دكتور تمام وصلت.
بس دكتور
Go ahead.
ال f prime of 0 كم تسوي؟
0. From here, if you substitute 0, this gives you 0, and this one gives you 0. 0 plus 0 is 0.
لا كوساين 0 1. وصلت خلاص عشان التين.